Alright, show that the following function is a one-to-one function, right? So you can show by using algebraic. This is an exponential function and this is a logarithmic function, right? So to show that this is a one-to-one function, I can use algebraic method, right? Algebraic method. Algebraic method. Okay, at first I will talk about algebraic method for both these. Right, for one, the algebraic method will be you have to equate the fx1 equals to fx2, right? So then you substitute the x1 into the exponential function. You have negative x1 plus 1 equals to e to the power of negative x2 plus 1, right? Okay, so then you minus 1 both sides, you subtract 1 both sides, then you have e to the power of negative e power negative x2, right? This will have the same base, right? We have the same base, so we can directly compare. So they will be equal if the index will be the same, right? Negative x2, and the result here will be your x1 will be equals to x2, right? So, and for 2, so your fx1 going to be equals to fx2. So means that the ln square root of x1 plus 2 will be the same as the ln square root of x2 plus 2 here, right? So since this is a ln, this is also ln, the logarithmic function, these two, the value will be the same if the function here will have the same value. So means square root of x1 plus 2 will be the same as the square root of x2 plus 2. And these two square root, the value will be the same if the function inside there, if the value inside there will be the same, right? So x1 will be equals to x2, right? Then getting the same result. So you have shown that this is a one-to-one function. So you have to explain, since both here you can make a same conclusion, since fx1 equals to fx2 imply that x1 equals to x2, therefore fx is a one-to-one function, right? One-to-one function. So does the f inverse exist or not? For this case, yes, the f inverse do exist. So the f inverse exists, right? Why the f inverse exists? Because fx and this both fx is a one-to-one function. Okay, this is algebraic method, right? So graphically, it will be okay. Let's look at the graphical method. All right, let's look at the graphical way of showing that the graph is a one-to-one function. So you know that how to sketch. Okay, you're going to revise how to sketching the graph of e to the power of negative x. If you want to see back the video that I teach you how to sketch the graph of exponential function, so you can go to that video. So for now, very simple to sketching the graph of an exponential function. First, you have to know that for exponential function, there is always have a horizontal asymptote here. So then the graph, if there is a positive here, the graph will be if there is positive, the graph will not be below the horizontal asymptote. The graph will either going up to the right or going up to the left, to the right or to the left. So it's either 1 or 2. In this case, if there is a negative here, this will be the one that going to the left here. So means that I can refinalize, the graph will be going this way, right? So then you can straight away sketching the graph. Very simple. If you know the technique of sketching the exponential function, you will be very good in understanding the concept of exponential and logarithmic function. So you see that positive one here, right? Positive one. The positive one here is actually represent the horizontal asymptote here, which is y equals to 1. Y equals to 1. So if this is negative 2, it will be a negative 2, right? So now you know the graph will be going this way. So which they will intercept the y-axis. Intercept y-axis, x have to be 0. So y equals to e to the power of negative x plus 1. So intercept y means x0, right? So we'll be getting 2. They will intercept at 2. So the graph will be going in this way, right? Going in this way. So as you see that if we want to using graph to show that this function is a one-to-one function, very easy. You just draw a line such that the graph will fail, right? But this line fail means intersect more than 1 point. So but this graph, if you draw anywhere, there is always passing through 1 point only, right? So this clearly shows that this graph is a one-to-one function. All right, the line y equals to k, the line y equals to k, where k can be any value, right? So intersect, we use the word intersect the graph of fx at most 1 point, right? At most 1 point. Therefore f is a one-to-one function, right? One-to-one function. All right, let's look at the graph for fx equals to ln. So okay, fx equals to ln square root of x plus 2. You can rewrite this as ln x plus 2 to the power of half, where the half you can bring it down and your fx will become half ln x plus 2, right? So you have to have some technique of sketching the graph so that you can use the graph to show that the function is a one-to-one function. So for sketching the graph of ln, the first step is you have to identify the domain, right? The domain. So the x plus 2 must be more than 0. Because the value inside the ln must be positive, right? So x must be greater than -2, right? -2. So then you know that this will be your domain. And then you know that the ln and exponent, what's the difference? The exponent always have horizontal asymptote. And for the ln, you always have a vertical asymptote. It's either the graph will be go to the right or left here, right? So based on the arrow here, the domain, more than will be on the right and not here, right? So if on the right, it will be either going up or going down, right? So it's either 1 or shape number 2 here. So which one to choose? If you see there is a positive, you see there is a positive here, right? Positive. So the graph will be 1, right? The shape 1. So if there is a negative here, it will be choosing the 2. So now you have clearly know that I redraw. The graph will be, the shape will be going this way, right? Going this way. So now the third step is I sketch the axis and I put the -2, the vertical asymptote here, the -2, and they will surely intersect. The graph will be going this way, right? Going this way. So they will intercept the y-intercept. So y-intercept, x has to be 0. So x is 0, so it will become ln. The y will become equals to ln 0 plus 2, ln square root of 2, right? Ln square root of 2, which is a positive, I think. So ln square root of 2. So the graph will be moving this way, right? So now you want to use this graph to show that it's a one-to-one function. So you draw a line y equals to k. If you try to observe this line, if they're moving everywhere here, they will only intersect the graph at most 1 point here. So then we say that this function, the logarithmic function, is a one-to-one function. So the same sentence here, and the inverse of ln square root of x plus 2 exists. Okay, that's all for this video.